Hey everyone, thanks for joining us today. Today we have a awesome meeting. Again, this will be our final one for the summer. Couple of announcements that we do want to make. We are in the works of a workshop on obfuscation. So keep in tuned. We will let you know what the official date is. We're looking at probably before school actually starts, but once we've finalize the date, we will be posting an announcement about it. So keep your eyes on the announcement. That is basically it for like the things that are coming up that you need to be aware of. But for today's session, we'll start off with the news, and then we will go into a Rick's Repo rundown. Unfortunately, Nick is not here to actually give the talk live, so he did provide us a recording, so we'll use that, and then we'll take a break. And then Jess actually has developed an amazing workshop that she's delivering virtually on IoT devices and how they work and how we can use them on simple like wireless applications, and she's going to be using the ESP32 device to demonstrate it. So without further ado, we'll start off with the news.
Awesome. Super excited for that talk by Jess, by the way. I got a little sneak preview earlier on in the week, and it's pretty cool stuff. Okay, so let's start off with, in my opinion, as a longtime iPhone user, just some pretty wild stuff going on in Apple land. Apple's neural hash algorithm is, I'm going to tell you more about this technology in just a second. It's going to be used to scan user devices, ultimately to catch child abusers. Now, Apple said that they're going to be rolling out this new technology with iOS 15 and macOS Monterey, and it's, like I said, it's going to be used to scan user devices for known hashes of child pornography. Now, clearly this is, in the grand scheme of things, I guess it's awesome because they're going to be catching child abusers. They're going to be getting thrown in jail. It's going to be pretty cool stuff. But privacy advocates, ton of security researchers, and loads of Apple users, especially on Reddit, are very, very resistant, saying that this technology is an invasion of privacy. Apple's saying that this neural hash feature is actually incredibly secure and super privacy conscious, and that the photos that are being scanned will not be decrypted and manually reviewed unless something that I guess is like a real crypto thing. I only just heard about it while I was reading this article, but unless something called the cryptographic threshold secret is crossed, which Apple's not revealing what that threshold is, but they're claiming with certainty that users' photos will not be accessed unless the content is nearly guaranteed to be illegal. Apple's saying there's a 1 in a trillion chance of a false positive. Apple has, in recent events, in recent times, just a few years ago, they've actually shut down federal services who have tried to access user data, I think on an iPhone, if I'm not mistaken. And that was for the sake of like a terrorist threat. It was an investigation of like terrorism, and Apple basically didn't break. They said, we don't have access to that stuff. We can't let you in, Mr. FBI. More recently, they actually had plans to implement a full encrypted iPhone backup to iCloud, but they dropped it after the FBI said that it's going to hinder investigations. So Apple is this company that has, tons of privacy conscious stuff in its background, and now they're kind of changing gears a little bit. I mean, at least to privacy conscious people, I think the average Joe is not going to know what's going on. They're not going to care about this at all. But yeah, wild stuff. Just to clarify, by the way, these similar types of scans that Apple is going to be implementing, they've been happening on cloud service providers like Dropbox, Google, Microsoft, a ton of other companies. They've been happening for a long time. Like your stuff gets scanned if it's in their infrastructure. It's just a matter of in this situation, this feature is going to be on the device that you've purchased on your own hardware. So that's kind of the thing that people are freaking out about, is that, if I have my phone, it's my phone, right? I'm not uploading my stuff onto your cloud. I'm not, I have nothing to do with you. I bought this phone. So wild stuff. Wild stuff.
Thank you. Yo, so that's kind of crazy because me being an iPhone user, I definitely did look into this because with iPhone users, the iCloud is probably one of like the most useful things for me. Just so as soon as I get Wi-Fi, bam, I upload all my photos. But I'm very interested on how iPhone's gonna, or Apple, I guess, is gonna deal with that. But for the
Yeah.
next one, I'm gonna talk about crypto hack. Pretty much it's one of the largest cryptocurrency hacks to date, with millions of stolen decentralized finance or DeFi of a Chinese platform, Poly Network. Pretty much this platform, which stole over 600 million from the cryptocurrency, all with a simple code of the function was in quotations underscore execute cross chain TX. But pretty much what this code does, it dictates between contract cells and it's tied to interoperability needed to communicate between independent blockchains. Pretty much these tokens are associated with a specific blockchain. As of now, up to date, what I looked up recently, so far the hacker has returned over $4.5 million worth to the company. But the Poly network, pretty much what they want to do is they want to develop a computer protocol or set of rules that allows the user to transfer tokens tied to one blockchain for a different network. But yeah, so far, like with this, they stole millions of cryptocurrencies, and yeah,
Okay. Okay, so this one I actually found kind of scary. It seemed like kind of like a almost like a supervillain kind of thing that like you'd have to be like really evil to kind of do this, I think. So basically, researchers from McAfee found out that the B Braun Infusomat space large volume pump and the B Braun space station, which are basically the space station is like the controller for the pump, and the pump is the actual pump. They were found to have vulnerabilities that can be exploited to double a patient's dose of a medicine, which obviously that's super dangerous. Supposed to be very specific doses with these kind of machines. So any changes, especially doubling, could like potentially be fatal or at least very harmful for health. A few years ago, I believe in 2010, they found similar vulnerabilities in these machines, but they were believed to have been locked down. But these McAfee researchers were able to find ways around. So they found that an attacker with access to the facility's network could use it to take control of the pump by using a common vulnerability. And then they could use a few other flaws to double the dosage. So this is kind of a bit of a complicated hack, like using 4 different vulnerabilities to do it, but it's still possible. And then this kind of creates a worst case scenario where the attacker is able to move themselves from the workstation, the control station, and the pumps system, which part of the lockdown was that you weren't supposed to be able to do that. And then they'd be able to change the doses and potentially kill people. So I thought that was super scary.
That's terrifying. Definitely terrifying. Yeah, so Coloradans are unable to find cyber work after a salary transparency law goes into effect. Apparently, roughly 500,000 unfilled cybersecurity jobs isn't a big enough deal for some of these companies to exclude Coloradans from having access to job postings due to a recent law that took effect January of this year. And that law is the Equal Pay for Equal Work Act, which requires employees to include compensation in job postings and keep job descriptions and wage records for 2 years after an employee leaves the company. Salary transparency has been shown to lower the wage gap at all job levels, as found by PayScale in a 2020 study. Violations of this new law could result in fines of up to $10,000 for employers. This next one is like I always knew that this was the real thing, but just seeing these numbers and seeing it actually researched by this article is wild to me. Women and people of color are routinely paid less than their white male counterparts, and this law is taking this battle head on in an effort to ensure equality all across the board based on ability and skill rather than other factors like race or gender or anything like that. The wage gap between women and men is roughly $16,500 in cybersecurity jobs, according to a study from ISSesquared. 16,500. Some of the companies that actually pulled their listings based on this law are big name companies. The companies that have excluded Colorado from these opportunities include Rackspace, Accenture, Contrast Security, CrowdStrike, and nearly 150 more, according to this website that Aaron Batillo, this engineer from Colorado, found, called Colorado Excluded. This to me is, especially just like with us getting into the workforce and stuff. This is huge, and I know there's a huge push for pay transparency across cybersecurity, employees across the world. I know that I think Kyle, he's in this chat, he linked me to a thing on Reddit where people are just willingly posting their salary so that people going into this industry know exactly what they should be worth or what they should be asking for. Transparency, big deal.
Thank you, John. Awesome. So next one we talk about the something that happened in Singapore. So recently, as of like maybe two weeks ago, recently Singapore Teleco, which is a telephone company, leaked personal data over 57,000 customers. Right now, StarHub is in the process of notifying of all those customers via email, which you can think of a kind of a hassle, due to the recent leak. So far as of now, even up to date, StarHub hasn't explained, um, or has any evidence of this data being misused, but that data is out there for on the dark web. Right now, StarHub does claim that credit card and bank information was not compromised, but nonetheless offered the all-effective customers 6 months of free credit monitoring, which is honestly really useful because if you know your telephone company got hacked and you know that your credit card, bank information, address, name is all out there, your credit card is pretty much active to whoever has access to whatever this leaked information was. So a good thing that StarHub is doing is say, hey, we realize we messed up. We're sorry about that. So for the next 6 months, we'll offer free credit monitoring to make sure that your credit card isn't being used without your permission. Which is really cool. But they did throw in a catch saying that, hey, you must be able to like identify this or act upon it before September 5th, which honestly I think is kind of fair so no one can abuse it by holding on to this, like, I guess, free credit monitoring for too long. So they did set a timeline like, hey, you have to December 5th to let us know if you want free credit monitoring, which I think would be really useful, especially if credit card and bank information is out there to the world. And lastly, so far this data breach was discovered on July 6th, but once again, it wasn't fully announced by um, Singapore Telco up until August 6th. And then this article was written on August 12th about the recent leak. So like honestly, like, if I thought like Cogeco, which is I think my family's telco provider right now, if I found out that our information got leaked, I don't even know if I'd accept the free 6 credit monitoring because honestly, I would just leave into a more secure telecompany because these guys didn't really do anything up until like recently. And this, as I said earlier, this breach was in July 6th. So that's almost a full month where your information was out there without you knowing. And all you get is an email saying, hey, we're sorry, for the next 6 months, here's free credit monitoring, which is in my opinion kind of messed up. But yeah.
Okay, so this one's another one about Singapore, kind of a coincidence. So Singapore's governmental technology agency had a study where they found that the deep learning language system GPT-3, along with another AI, could make phishing attacks simpler and more effective. So basically, they conducted an experiment to figure out whether phishing emails created by AI could compare to phishing emails crafted by a human. So they targeted 200 of their colleagues with specifically crafted phishing emails from the AI and from them. And the links were not malicious, but they just tracked how many people clicked the link and went onto the website. And so they actually found that many more people clicked on the AI-created emails than the human-made ones. And so normally you'd say, okay, AI is expensive. Like, not everyone's going to be able to use AI. It's hard to use, takes a long time, and it's expensive. Which normally that would be the case. But there are third-party providers such as AI as a service, which would then allow these attacks to be used for only a couple of cents. And they also found that these third-party providers don't really have that many verification or anti-abuse measures. A lot of times you don't even need to put in your email or verify your identity at all to use them, which, because AI is so powerful, you'd think that there'd be more verification there. Because like right now, anyone can take one of these AIs and, as shown here, can create like phishing emails with them or other types of attacks. And these phishing emails were a lot more effective than the human-made ones.
All right, Pablo. I see your 57,000 breached telco customers and raise you 100 million. Okay.
Right on.
T-Mobile. That's right. It's a pretty big raise. I don't know if you can call it, but T-Mobile is hacked again. As Motherboard was investigating social security numbers being on sale at an underground forum, they've inquired further with the seller who was selling this data and got confirmation that this data was in fact from T-Mobile customers. The seller said that there's 100 million customers' data in total that was compromised, but the post was only selling 30 million of them for a total of 6 bitcoins, which I think at the time of the article being written was $270,000 US. T-Mobile has already addressed the breach, and they said that they in the announcement they said that the entry point which was used by the attackers has been closed. Motherboard actually analyzed the samples of the data, and they were able to confirm on their own that this information obtained on the T-Mobile customers was in fact legit. Like, this is a real thing. Beside the social security numbers, some of the data that was collected included phone numbers, names, physical addresses, IMEI numbers, which is kind of like the serial number of the device, and driver's license info. So yeah, that 6-month credit monitoring deal, I think these guys could definitely use it. I think the thing that's super crappy about this, though, is that this is the 5th time in recent years that T-Mobile has been hacked. And as one of the biggest telecom companies in the world, I mean, 5 times. I don't know. You were talking about leaving Kojiko if this happened to you. I don't know, man. 5 times is pretty heavy stuff. I'm
so surprised they're doing well right now, because I've definitely heard multiple. It's like, oh, T-Mobile hacked again. Oh, again. So
5 times. And there's no pointing fingers, obviously, but I feel bad for the customers, right? I mean, you go back, maybe they get the best deals in the States. I don't know. I don't know anything about States telecom, except it's much cheaper than Canada. But man, imagine being a customer through all these years and not leaving, right? And just, it's scary stuff.
yeah, no, like with T-Mobile, it's crazy how the states work. I guess they have some crazy. There's like, hey, you've seen 6-month credit monitoring. How about 5-year credit monitoring? It's gonna keep getting hacked.
Jeez.
But next, here's one that I actually really found really interesting. Just because I'm not from Singapore, so like that, but I do use Steam a lot. And recently, Steam, there is currently a bug where you can have unlimited funds to your Steam wallet, which sounds like a gamer's paradise. So, pretty much this code abused the smart to pay system to add unlimited funds to the gamer digital wallet. Simply by changing the account's email address, the exploit would allow anyone to artificially boost their digital bill to anything they wanted. So, for example, with your email, you would put, for example, I'll just my name, Pablo amount equals 2,000. The email would override and see that command amount equals 2,000, and then override my Steam account into the amount that I've selected. So I think that's kind of crazy that someone discovered that they can just put code in their email, and the email will like override it as just a regular email into a regular like actual command. So pretty much this wallet is used to purchase in-game purchases, just in case you don't know how the Steam wallet works. It's just online currency for the Steam platform. HackerOne, which is a bug bounty program, researcher Dr. Bricks, Valve plugged the hole and was paid around 7.5 thousand for identifying this bug, which is honestly quite a lot for this bug bounty, which is actually really interesting for myself because this seems something that I would like to do in the future. So hence why I picked this article. Um, Valve's own application programming interface, so API, used communication with the third-party web payment firm from Smart to Play, owned by I don't know how to pronounce this, but Nuve, which is Steam's smart to pay system. But the way this worked was just the intercept through a post request, once again through the email override, and smart to pay system didn't recognize that email and recognize it as a code. So from there, anyone with an fake email or just an email with code saying amount 2000 would simply transfer over into the user's online bill or online wallet into real life currency for the Steam games. So yeah, I thought this was really cool because I'm like, you can create another email, put a fixed amount in your email, and the smart to play system would read it as a code or as a command and change your current whatever money like amount you have in your account into whatever your email hard coded was.
Okay, so going back to our southern neighbors in the States. So the White House, actually yesterday, so this is a little out of date, but is hosting a cybersecurity conference as part of a larger call to action to improve security across the nation. So this conference included like a lot of big names, including the CEOs of Apple, IBM, Alphabet, JP Morgan Chase, and Amazon. I think Microsoft was also there. I think I just not missed it. Um, and as well as other insurance, energy, and water companies. There were also what I found interesting is they brought in a lot of organizations that teach about technological skills and security skills to kind of help out with this. And so they're looking to, so this meeting and this initiative came about after many cyber attacks on many industries across the nation. I think they kind of got the feeling that it wasn't just the private sector being hit and being affected all the time. Like, for example, the Colonial Pipeline, which was a huge hack a few months ago. And it's hitting a lot of things. So they figured we have to kind of team up to improve security. So there were a lot of different talking points, such as ransomware, shortage of cybersecurity professionals, and as well as improving general security. And it hasn't been confirmed yet. No one said anything, but they believe that this initiative will also work to try to pass legislation dealing with cybersecurity to kind of create more standards that different companies have to meet, like legally. So then that'll help improve security. And they kind of brought in all of these different CEOs and companies to get them to also say that they're following this and that they're also going to be trying to implement more security measures. Yeah.
Awesome. Thanks, guys. Beautiful job, as always. Up next, what we will have is the recording for Nick's Repo Rundown. So I'll just stream my screen and everybody can view from off of. Okay.
Hey everyone, it's Nick here with another Repo Rundown. I thought this time we'd take a look at the Mirai botnet, which is a pretty notorious Linux IoT device botnet. We're just going to look at the client code, so the actual process that would execute the distributed denial of service attacks. There's a number of other components to this that maybe we can look at in future episodes, things like the downloader, the loader, the command and control server, things like that. And even then, I'm only going to have the opportunity to kind of cover this at a high level initially, and again, maybe some other time we can do more dives into it. The source code was posted by the original authors on like a hacking forum, and it is available on GitHub at the address there if you want to see it. A note about the authors. The primary author that goes by the handle Anna Senpai was actually, at the time that they wrote the software, a student at, I think it was Rutgers University, and was the founder of a DDoS mitigation company, which is kind of funny because eventually they would go on to use this DDoS botnet to kind of extort people and threaten them. So a little bit of neat info there about that. A little more background. There's tons of information available about this. It's a pretty, famous piece of malware. The Wikipedia write-up is pretty good. There's also some other good deep analysis of this malware. But basically the things you need to know are that it attacked networked devices running Linux and converted them into bots. Typically the things that it targeted were things like IP cameras and home routers. It actually has a bundled in list of like default root names or administrative usernames and passwords inside the botnet, because it would try to spread itself. Again, initially it was created to DDoS Minecraft servers and companies offering DDoS protection, and eventually was used for a number of other things. Now that it's also open source and on GitHub, other people can take it and modify it and have allegedly used it for other things as well. So the high-level organization of the code repository goes something like this. This top-level folder here, DLR, is the downloader. So that will go and fetch the malicious code from your server that you're running. The loader, which kind of helps to bootstrap and load the botnet over top of the whatever the device is that it's compromised. I haven't dug into these two very much at all. Then there's the main Mirai folder, which actually contains the bot itself that's meant to run on the client side, and the command and control server that sends out the instructions to your legion of botnets, and some scripts for things like cross-compiling. There are a number of build scripts in here that you can see as well that will compile the various tools for a bunch of different architectures. So if you want to look at something like this that has a bunch of different parts to it, usually the first question is, where on earth do we start reading this kind of stuff? So here's the path that I chose to take. I knew I wanted to look at sort of the main bot component, because maybe that would be interesting. Like, what does a piece of IoT malware look like? And when you drill down into this bot folder, you're presented with all these files. And because it's just a C program, obviously we want to look for something like main.c. If we didn't see that, maybe we would look for something at least that has a main function in it. Other stuff in here, we have a bunch of files supporting the various types of DDoS attacks that it supports. Some checksums for verification of some packet data, some includes, this is mostly like constants and things, code for identifying other services on the device that are using the ports we want to use, like port 80, port 22, port 23, and terminating them. Let's see, some network protocol stuff, a really interesting random number generator that's basically just based on time and a few other things. It's not actually pulling from any kind of like real random entropy source locally, so it is a little weak there, but it doesn't do a whole ton of crypto, so it doesn't really matter. DNS resolver stuff. This scanner is used for identifying other potential victims that could be compromised and taken over, like other IoT devices that you can scan for and infect. The table is used for kind of encryption and decryption of strings and operations. A lot of the built-in strings have been encrypted, and you just use some utility stuff. So if we hop on over to main.c, we see that it imports a whole bunch of stuff. On the left here, we have standard Linux C program imports, things like the standard libc library, some stuff for like Linux system calls and local interfacing stuff, some networking libraries, some stuff for process control. There is a multi-process component to this, so like it forks child processes that are listening, that are scanning, that are doing things, so you're controlling multiple processes at once. Handling some signals, which also, so these would be like messages that the process would receive from the system. There's also a little bit of anti-debugging signal handling, like if someone tries to debug this process, it has a couple of tricks that it will try to use to screw up that kind of reverse engineering or malware analysis. Some file control and IO control stuff, because we might have to read and write some data, time, system errors, things like that, and then some of the author's own libraries that they wrote, so a bunch of constants, and includes just for like shortcuts and things like that. The table library, which handles a bunch of obfuscated strings and commands, the random library, the actual listing of types of DDoS attacks that it can perform, like TCP and UDP and a number of other things in there. So process control and termination of other processes on the system. the finding and infecting scanner, so looking for other devices again that it could potentially infect, like scanning for telnet, I believe, is one of the things it does. Just standard utilities like string copying and manipulation stuff, and DNS resolver. So starting up in main, we declare a bunch of local constants that I'm not going to really go into. Some neat stuff happens here. This Mirai is fileless malware, meaning the malware doesn't want to have any actual files resident on the system that it's compromised. It makes forensics and analysis harder, makes it harder to find. So actually one of the first things it does when it starts up is it unlinks arg0, and in C, arg0 is always the name of the program that has just been executed. So essentially the first thing it does after it's loaded itself into memory is delete its own file. That was one of the things about Mirai. If you simply reboot the device, like unplug it and plug it back in again, the Mirai malware would be gone. It would need to be reinfected all over again. Because again, it deletes its own file off the hard disk or whatever storage medium the IoT device is using. Again, some signal handling stuff, like what signals are we going to respond to, and then some stuff around the anti-debugging feature just to kind of trick people and make it harder for malware analysts to look into. A lot of hardware devices have things called watchdog timers, where if something seems to be stuck in an infinite loop or not responding, these hardware watchdog timers will reboot the device. Again, because rebooting a Mirai infected device will effectively erase the malware, Mirai wants to actually disable the watchdog timers, which is what this function here does. It tries to find, like, is there a watchdog on this device we've infected? If so, open it up and send it the signal to disable that watchdog process. Okay. Then it actually sets up some pretend command and control addresses, again, to screw with people that were trying to reverse this initially. Either legitimate malware analysts trying to figure out what this thing does, or other malicious botnet operators who would maybe trying to hijack this malware and attack and gain control of CNC servers and stuff. But these are actually fake. Yep. And it also wants to ensure that there's only one primary instance of the malware running. So ensure single instance is what this does, so that it doesn't kind of keep spawning itself. It's sort of like a singleton guarantee thing. We initialize the random number generator, which is just we grab a system time and do some multiplication. And we get any other arguments and things like that. Again, other things that the botnet does to hide itself on the local device, hides argv at 0, so it'll actually go in and here we go. We're string copying this buffer here, which is just a random alphanumeric string over top of the string arg0. So even if someone does a memory dump, they're not going to see the name of the executable that launched this malicious process, because maybe you compiled it and it was still called Mirai.c. right, or Mirai.out or Mirai.exe or something like that. That string, that word Mirai, would still be in arg0, even though we deleted the file off the file system. The name of the process is still there, or the name of the file is still in that argument if someone did a memory dump. So now we're going to overwrite that with a bunch of random data. So now even if someone gets a process listing, they're not going to see like Mirai as an executing process. They're also going to hide the process name itself. Through process control, a process can change its own name. Again, a random alphanumeric sequence gets generated and used as the process name. And then it just prints a little message on standard out, I believe. Yeah, standard out. It just says, hey, it's up and running. Then the process forks itself, meaning making a duplicate. And then it closes standard in, standard out, and standard error, the terminal, the ability to like input commands on the text console and stuff like that. And then it initializes some of its capabilities. So the attack routine initialization, looking for other processes that are using telnet SSH FTP, shuts those down and prevents them from restarting, so we don't interfere with the botnet operation. And then it also starts the scanner process that will look for other targets to infect. The attacks, really quickly, are kind of interesting because they're written just as a series of functions, and they can kind of work like plugins. It loads them all from one of the headers. It loads them as just dynamic kind of functions that we can call. So that's how the attacks are structured. So then the program enters its sort of main execution loop, which is pretty straightforward. I mean, this is it seems like a lot of code and it goes on for a couple of pages, but really what this all boils down to is the bot essentially tries to connect to the command and control server. If it doesn't establish a connection, or it sort of times out, or it hasn't heard from the command and control server in a long time, it will basically self-terminate. It will start killing off its processes and things like that because something's gone wrong. Either maybe the server's gone down or something like that. Or it's being intercepted and it doesn't want to get caught. So it's going to basically, terminate all the stuff that it's doing and exit right there. At which point the malware would be erased from the system because the system is probably going to reset after this exit happens. So that's kind of what most of this is here. Essentially, otherwise, there is like a little heartbeat or ping routine that we are using to make sure that the bot is still connected with the primary command and control server. But all that aside, the main kind of meat of what's going on is down here, sort of at the very, very bottom of this loop in main, where we've actually received a command from the command and control server that is not just a simple ping. Because one of the things it does is, as it receives a command from the control server, if the length of what we just read is like nothing, it's probably just like a heartbeat, making sure that we're still connected to the server. So we're just going to skip it and not even parse it. Otherwise, we're going to basically read the full contents of that message that we received from the server, and then pass it over to this function that's going to parse the attack. Because the way this works is this server is going to send instructions to these botnets, to these nodes. We can look at the server code another time, but basically it's going to send either a target or a list of targets and a type of attack that should execute, and a duration, I believe, as well for the attack. Although I think the duration could be like, execute indefinitely until we tell you to stop as well, I think. Again, I haven't dug into some of those too far. But ultimately, we're waiting until we eventually receive a connection from our server, or a message from our server, and we read that data out of that network socket, and we pass it over to this attack parsing command, which is inside attack.c. So what does attack parse do? So it reads in the attack duration as an unsigned 32-bit integer. So that's, I guess, how many seconds it's going to execute for. We read in the attack ID. So there's a bunch of constants that define the type of attack that we're going to execute. So these could be, again, like a generic UDP, flood, or a series of TCP connections. They're all enumerated in one of the attack files. Let's see, we also read in the target count. So how many targets do we have? And we read in all the targets. So we could have a whole series of IPs that we're targeting, not just a single IP address or a single domain or something like that. So we read in all those. And there's some flags and some other details and some options that we can read in as well that are less important. But the main thing is we're going to figure out what kind of attack are we doing, how long is it going to last, how many targets do we have, and what are they. And then once we've figured out all that stuff, it starts the attack with all of those variables being passed into the attack. Now, there are a number of different ones, but those will get called kind of right down here. So here's our start attack method, where again we fork the current process. So we've got a couple of child processes that are going to be executing this while main continues to sit in that loop and wait for new instructions from the command and control server. The child processes down here are then going to look up and see, hey, what attacks were loaded when I was sort of bootstrapped, and then it's going to basically call one of them, depending on which attack we were given, which is what this vector up here is. We're extracting that from there. Okay. Throughout the code, by the way, I haven't included a lot of this. There's a ton of debug information, but it uses these C directives where when you compile it, if you compile your program, if you compile a program with a debug flag, you'll notice it prints out all kinds of debugging information. But then there is if that flag is not present, it will enable some more protection features. Like I cut some of it out, but for example, this line near the beginning where it deletes itself, this entire block of code will only execute if you're not in debug mode. This is like the kind of production mode. If you're in debug mode, it just skips over all this, because the authors, I guess, while writing the program, didn't want to be constantly like having to delete and reinfect their own IP camera that they had. So hopping back over to where we were. Eventually we get down here and we're going to call the particular attack that we want to execute. So here's one of the attacks. So this one is attack_udp.c. It's in one of those folders that I showed you earlier. And the way it works is pretty straightforward. So here's one of the versions of UDP attack UDP plane. Again, it takes how many targets are there, and here is a list of the targets, some options for the attack, and what those options are. Again, how many options and what are they? Here we're just sort of extracting some of those details from those parameters, like destination port, source port, how much data, if it's going to be random data or not that we're sending to the target and to the servers that we're targeting with this attack, and stuff like that. And then basically, since this is going to be a UDP attack, all we do is set up a socket locally, and with sort of the IP of the target as sort of the thing we're going to be connecting to. So we connect to it, although since it's UDP, it's connectionless. We're not like really waiting for a response, but that's still the function name that we use. We've made our own local socket though that is going to point outwards. We connect to it, and then we enter this little loop that then just sits and runs forever until the server is eventually given the instruction to stop running the attack or reboots. So for each target that we have, we sort of kind of create this chunk of random data. If the random data field was set as one of those options, rand_stir just generates a string this long of random alphanumeric characters, and then we send it to the victim machine over UDP, and that's it. It's just, we just sort of start blasting out these UDP packets, and then this is just going to sit in this loop executing over and over and over and over again. And we've got a couple of threads doing this as well. So that multiplied by the number of infected cameras we have, and we end up with these massive DDoS attacks. But that's really all it is. We're just opening a local UDP socket, pointing at our target, and then just sending it strings of random data. And that's really all that there is to this. And that's sort of the Mirai botnet, at least one piece of it in a nutshell. So if you're interested, we could maybe in a future episode dig further into this. So maybe to be continued. I don't know. Let me know. Anyways, thanks everybody, and I hope you have a good rest of the session.
Great. Thanks, Nick. Right. So I think now we'll take a 10-minute break. We'll come back around, 7:56, 8:05, and then we'll start with just a segment.
Oh, sounds good.
So, hey everyone. Today we're going to be going through some cool wireless applications using the ESP32. This is a popular microcontroller used in IoT devices, and just as a disclaimer, I am by no means an expert on the subject matter. So if you see mistakes in the slides or if you have questions and you see me Googling the answer, that's okay. We're going to learn together. So just a short blurb, my name is Jess. I graduated from Sheridan's Computer Engineering Technology diploma program in 2018, and then I bridged into ISS. If you also came from the same program, a lot of this content will be familiar to you. I technically graduate in about 5 days, and starting next week, I'm going to be working as an IT security analyst for Life Labs, which is where I did my co-op. So the Internet of Things, at the core of it, what does that really mean? IBM describes it as a device that connects to the internet and to other devices, which is pretty basic. So we're all aware of devices that connect to the internet, but devices connected to other devices are common in what are called wireless sensor networks, and these use a variety of different technologies. Some of these you're familiar with. For example, Wi-Fi, it has AX, AC, NG, A, and B protocols. AX is the newest, and it's the coolest because it supports 2.45, and eventually it'll support 6 gigahertz. So Bluetooth, you have two that are still in use. You have Bluetooth Classic and Bluetooth Low Energy. Near-field communication uses active, passage, and switching devices. You also have cellular. You have the COVID-inducing 5G. You have 4G, LTE, or commonly known as 4G LTE, and 3G. Zigbee, you have 3 different device types. You have a coordinator, a router, and an end device. And for Z-Wave, last year they just announced Z-Wave Long Range, which is supposed to get rid of eliminators, so that's neat. So IoT devices have what's called a microcontroller inside of them. This handles all of the data processing. So a microcontroller is a small integrated circuit used for specific operations, and it's usually found in embedded systems. It's comprised of 3 basic components. It's a CPU, some sort of memory, and I/O ports. If you're in your 3rd year or later, you may have heard of the term microprocessor, and while they seem similar, they're not. So a microcontroller is used for simple but very specific tasks. They don't have an ALU, so the math is all done on the software level. This makes them really bad at processing numbers, and they also typically run at less than 1 gigahertz clock speed. They're also specially designed for real-time tasks such as deploying airbags, sensing fires, or giving medicine dosages. So a microprocessor, which you may have come across in your CPU class in the form of an 8086 emulator, that's what's found in your computers. It's general purpose, it's used in incredibly complex systems, and they have a built-in arithmetic logic unit, that's your ALU, that makes them really good at math operations. And they almost always run faster than 1 gigahertz. And because they use a lot of peripherals and can be pretty complex, they're not very good at real-time tasks. So the specific microcontroller we'll be looking at today is the ESP32 by Espressif. So the room version has Wi-Fi, Bluetooth Classic, and BLE built in. It also has touch sensors, Hall sensors, an interface for SD memory, SPI for flash, UART for device communication, I2S for sound, and I2C for IC integration. So the most important part about why we're using this, though, is 2 main reasons. One is that in 2018, 100 million of these chips were shipped out for IoT devices. And they're used in automation, healthcare, consumer electronics, and smart home devices. So that means that these chips are being actively used in the wild. So they're out there, they're in use. And part 2 is they're really, really, really beginner friendly. Microcontrollers, by nature, they're not easy for beginners, but anyone can pick up an ESP32 and get it to work in a few minutes. So we saw the chip earlier and what it looked like, but in order to interface with it, we're going to be using what's called a development board, or sometimes called a discovery kit. So companies make these boards so that developers or hobbyists like us can use the chip to prototype our applications. They come with firmware for debugging, such as JTAG. And I mentioned before that the ESP32 is especially friendly, and that's because you can actually program in Arduino, which is in C++. The native way of programming is through the IoT development framework, which is written in C, and it requires a lot more work to achieve the same thing. So let's start out by making a very, very simple circuit. So this is the equivalent of Hello World in most microcontrollers. All you're really doing is getting an LED to turn on. In our case, we're going to make it blink. This tests the output. For us, we only have 2 components. We have a 1 kilo ohm resistor and a single LED. If you look at the board, you're going to see a lot of cool things, and they may not make sense to you, but that's okay. We're only really concerned with 2 pins. So this pin right here, GPIO5, is what we'll be using to turn our light on. It's going to connect to our resistor, which is going to connect to the LED, and finally to ground to complete the circuit. Let's take a look at how we can get this done on ESP32. So first thing we're going to do is just install the Arduino IDE. Again, we're starting completely from scratch. And it's going to ask you to install some drivers. Just press yes on them. So if we open up Arduino, you're going to be greeted with a basic sketch. And so to set it up, we want to set up the board manager. So we want to insert here is the JSON link where it downloads the board manager from. So here's the link. Let's just paste it in. We press OK, and then next we're going to go to Tools and choose the board. And again, right off the bat, you won't see ESP32. We'll have to download it. So just click here, type in ESP32, and just install the newest version. So once that's done, you can select the board, and you're going to see a lot of different firmware here, and it's because each board manufacturer will sometimes work with Arduino and post their own different pinouts. For us, if you don't know what you're doing, just go to the very top and click on ESP32 dev module. So what's next? Well, let's go back to our circuit diagram. And if you can see on the right-hand side, it's a match to the left. So you have on pin 5 or GPIO 5 is connected to our resistor, which is then connected to our LED. And finally, that's connected to ground. So how do we get this to turn on? Now let's go back to Arduino and let's write some code. So the first thing we do is specify the LED we want to turn on, just as it's pin 5, so we want to just write it as LED 5. Next, we first have to actually tell the board how we're going to use this pin. It can be used as both input and output, so we have to explicitly tell the board that we want to write data to this. So here we're going to write in pin mode, the LED, and just write it as an output. Next, we want it to blink, so we're just going to use the built-in function digital write, the pin we want to write, and then the second parameter is the state, so in this case high. And we want it to turn on for 1 second, so we just put in a delay of 1,000 milliseconds. And now we're just going to turn it off, write the same thing. Once that's done, you just want to compile this. Just click on the top left-hand corner, this little check mark. And you'll see it compiling Sketch. So once it's compiled, you just want to upload it. But first we have to plug in the ESP32. So let's plug it in. And if we look back to our board, you can see that it's lit up just to see it's powered on. So the first time you plug it in, you'll see it download some drivers, and that's okay. So now to get it into the ESP32, you just want to click the upload button right beside the check mark in the corner. Ooh, error. Okay, so it says serial port not selected. So yeah, when you first plug in a microcontroller, it's gonna be assigned a port, and you have to figure out which port that is. So the easiest way to do that is just to go to your device manager, go under ports, and then see it's connected to which COM port. So it's COM port 3. We go back into tools and we can select which port we're going to program to. So it's the only port there, COM 3. Now that it knows where to send that data to, we can just upload it. So once that's done, you should start to see your program work. So if you go back, and again, if you don't see it working right away, you may have to press a reset button, but for our case, it works right away. And just in case it doesn't work right away, you can press that little reset button in the corner. In our case, it works right away. We don't really need to do that, but in the next demo, we'll see how to do the same thing, but we'll do it through a web app. So before we move on, I'm just going to take a look at any questions. Okay, so how do we download the emulator? So this actually, for the demo that I'm doing, I don't actually have an emulator. I'm not actually sure if there's an ESP32 emulator. Find out. Oh, there you go. So Abdul posted something. Again, what I'm doing is a little specific to the ESP32. It's not completely an Arduino board, but I'm sure there are ways you could get around it. We'll see at the end that there's actually a raffle for winning 2 of these boards. So if you're lucky, you can be one of those winners. Also, these boards are fairly inexpensive. They're about $10. And the only thing you really need after that is to get a USB. Then you can do a bunch of wireless stuff. If you wanted to attach some more peripherals to it, like we just saw in the video before, you'll need small components like LEDs or cables. So if anyone has no more questions, so awesome. So we now have a basic circuit, but it's not wireless. So we need to make it wireless. So first we're going to look into setting up a web page hosted by the ESP32 so that we can control the light that we configured. So now that we're finally working with wireless, it's going to require more steps than what we saw before, but to break it down, we first have to set up a serial monitor. This is going to allow us to troubleshoot what happens if anything goes wrong, and it essentially allows the board to talk back to us. When we connect, next we connect the board to my home network by specifying the SSID and password. This turns the board into a soft AP. And after we configure what happens when the client tries to connect, and then we create the web page that we'll be showing the client. And lastly, we have to set up the HTTP responses for what happens when the client interacts with the page, and then we close the connection. So this is our second demo. Again, we're just going to turn our ESP32 into a very basic web server. Now, the reason we are using ESP32 is there's actually examples built in. So instead of writing it ourselves, we can just scroll all the way down to Wi-Fi, and we can see Wi-Fi, simple Wi-Fi server. There it is. So let's open that up. And this is essentially all the code you need, but let's just walk through it so we can match it up with the steps that we have. So this code is just written by Tom Yago and then ported for the ESP32 by Jan Henrik Berlin. As you can see, the first step is just specifying the serial. So here we create a new serial monitor with a baud rate of 115200. Next, we want to just set up that pin mode again because we are still using that LED. And next, we want to set up the Wi-Fi connection by specifying the SSID and password. So here they just have a generic one, but I will be posting mine. This is just a test network I made for this. So if we scroll down here, this is pretty much the board trying to connect to Wi-Fi. And we're just doing some print statements saying while it's not connected, just print some dots. So here we can also see the server specified. So here we're telling it, start the server on port 80, which, as we all know, is HTTP. So once we connect the board to Wi-Fi, it gets assigned its own IP, and this gets printed out to the serial monitor. So imagine on your computer you did IP config, that's what that line does. So in our loop, we'll be just writing what happens when we detect a client. So once it sees that there's data to be read and it sees 2 new lines in a row, it means that there's a client who's connected. So we display this web page. Here in the first few lines, we have our HTTP headers. And then after that, we have our HTML lines. It's just 2 basic HTML lines. It says, click this link here to turn on the LED and click this link here to turn it off. Next, we just set up the HTTP response of what actually happens when they click the links we just mentioned. So if they click the first link, it turns on the LED. And if they click the second one, it just turns it off. And lastly, if the client disconnects, we just stop the client and then we start all over again. Now, this looks simple offhand right now, but what you've really just created is the backbone of almost every single IoT devices. So let's compile it and then we'll upload. So this is our board and it's still using our previous blinking program. Now we upload. And once we upload, you'll see that LED turn off because by default. Yeah, we can see it turn off. And so let's open our serial monitor. Again, this is how the board talks to us. And we can see that our board has gotten a Wi-Fi IP address of 192.168.3.127. So it's serving up our web page just on that IP at port 80. So if we just go to that IP, so we'll get this basic web page, and this is the 2 HTML lines that we wrote earlier. So if we click that, it will turn on and turn off the LED like we mentioned. And this is Wi-Fi again, so you can do this from anywhere in your home network. And why this looks simple, this is the backbone of hundreds of different IoT devices. Instead of a light or instead of a small LED, you can use a smart light bulb. You can use this as a pet feeder. Instead of an LED, you would put like a stepper motor, which then opens some sort of hatch or door. You can use a fire detector, say your fire alarm's going off, you can just turn it off remotely from the other room if it's just a false positive. You can have applications in different toys or even just like PLCs and control systems. And that concludes this demo. In the next one, we're going to see how to use ESP32 as a client. So is there any more questions? We'll take a break after each demo for any questions. Yeah, garage doors are 100%. Yeah, you could use this with stepper motors with garage doors. Hey, people pay to get their lights to turn off without getting up. My sister just bought like an $11 light bulb that does the exact same thing. And the app that it's connected to is just 2 buttons. It turns on and off, and then there's another button for setting up a time so you can make money. So now that we have our board acting as a server, we want it to act like a client. So this way we'll use a TCP connection. So most of you are aware TCP uses like reliable packet transfer so that packets arrive in order. In this next demo, we're going to have our ESP32 act as a client, and we're going to connect to a server that we're going to make on our computer. So this server is going to be made using Node-RED. It's the easiest way to make a server for, it's a flow-based programming tool used specifically for testing IoT devices. And lastly, instead of just sending like hello world or just text data, we're going to start using the sensor. So the sensor is, we're specifically going to be using a touch sensor that is connected to the board, and we're going to send that touch sensor over to the server. Now, if you look at our pinout sheet, the touch sensors are actually these ones in pink. So there's 9 of them throughout the board. They are capacitive, not resistive. But since we were working in this bottom right corner earlier, we're just going to use GPIO 15, so the one on pin 15. So again, this is our third demo. We're going to be setting up our ESP32 as a TCP client. So most of the code is already written, but we'll be walking through what each section means or does. Since our board is a client, we do have to set up a server. We're going to be using Node-RED. So it's a JS framework specifically for testing IoT frameworks. So let's open that up. And once it's started, by default, it opens on localhost at port 1880. So if we just go there. So this is Node-RED. It's a very easy interface to create like IoT connections for like inputs and outputs essentially. For our purposes, since we are interfacing with a TCP client, we need to have essentially a listener. So here we have over here, we can see that this will allow or accept incoming TCP connections. That's exactly what we need. So we're just going to drop that down. And now we're just going to need a way to understand or see the payloads that are being sent. So we're just going to bring this down here and then connect them together. Now we do need some configuration. So if we open up this, we just need to tell it what port to listen to. For convenience sake, we're just going to put 1881, and right now the output is set as a buffer. And then for readability, we're just going to change it to string. And once that's all set up, you're just going to click deploy, and now our server is in the wild. Well, in my internal network. So if we take a look at the board, remember we're using the touch sensor on pin 15. So if you can see really close, this cable is connected to pin 15 or D15. The purpose of this is really so that when we touch the edge of this pin or this cable, it will give us a number that corresponds with the touch sensor. When we're not touching the pin, we'll see higher values, and when we are, we'll see lower values. Now let's take a look at the program for this. So same as before, we start off just by specifying the SSID and the password to connect to the network. The important difference is, since we're the client, we have to actually specify the server that we're connecting to. We set up Node-RED earlier, so to listen to port 1881, so that's where we want to connect to. And this host right here is the IP address of the computer or the hosting server. And this setup, you saw this before, is just our board connecting to Wi-Fi, and it's going to print its own local IP. And in the loop, every 3 to 5 seconds, we are going to try to connect to that host. And then down here is going to be the bit with our touch sensor. ESP32 has a built-in function called touch read. We are sending in the parameter 15, which is the port or pin number that we're going to be using. It's going to assign the capacitive value that the sensor sees to an integer, And then we're going to then pass that integer over to our server. And like I mentioned before, it's going to occur every 3 to 5 seconds. So let's just compile this. And then upload. So now that's done, let's open up our serial monitor one more time just to see what's going on. And we can see that it's trying to connect to our server at 192.168.3.114. So let's take a look at our server. Again, here's our message where it's going to read us the payloads that's being sent. And we want to see the values in the payload. So let's just click on that. This is the debug. It's going to allow us to see what's there, or what's being sent. And if we touch the pin, we can see that our sensor is getting a 6. And if we let go of the pin, we're getting higher numbers, 36. And it should jump up to around 50. There you go, 50. So now you can change this program. So instead of beaconing the values, so constantly changing the values, it'll only send the values or payload once it detects a touch value below a certain threshold. And it's really just a basic if statement. So if it detects a value, certain threshold, then it would send like, oh, hey, a touch was detected to the server. Now you can kind of start to imagine what kind of uses this might have in an IoT environment. This is especially useful in security systems, and just because we use a touch sensor, it doesn't mean you have to. You can switch out a touch sensor with a proximity sensor. Even built into the ESP32 is a Hall sensor. This detects changes in magnetic fields. So it would, for example, be able to detect if a door was opened. Or you could put in a photoresistor, which detects light, or a temperature or humidity, or like a microphone. So if there's a sound, you could alert something. Exactly. So what we have is 2 different kinds of circuits. One that controls the environment around it by blinking an LED, and the other one that takes in data or from its own environment. And these are the basic components that make up IoT devices. You're either gathering data or you're sending data. So that was our third demo. And in the next one, we are going to see how to use Bluetooth Low Energy on the ESP32. So we are almost done. Before we get to our last bit of the demo, does anyone have any more questions? Okay, I'm not seeing any questions. Oh, wait. I'm very glad that you think so, because this is the culmination of my 3-year diploma. So very happy about that. Oh, thank you. Okay, so if there's no more questions, let's just continue. So before we go, so now that we can make a circuit and we can use the Wi-Fi module, let's look at other wireless module. We'll be looking at how Bluetooth Low Energy works. We're going to be examining the GATT protocol. So some background info on BLE. It was essentially supposed to be a successor to Bluetooth Classic, mostly meant to compete with Zigbee. And it's generally 10 times more energy efficient than Classic because it has a sleep mode. It's very common in wireless sensor networks, and it has an incredibly different protocol stack than Classic. So one of the protocols BLE uses is called GATT, General Attributes. It's a data transport protocol that defines data in a hierarchical structure. And the most important thing you need to know is that each device or profile has a series of services. And then each of these services has at least one or more characteristics. And then each characteristic has a value, it has properties, and it has an optional descriptor. At each level, service, characteristic, and descriptor, you will find a UUID, a universally unique ID. This is a 128-bit number that is unique. There are also some predefined characteristics in UUIDs for specific services. The heart rate, for example, has a default prefix of 180D, a battery service is 180F, and device name is 2A00. So here's an example of heart rate. So you can see that this heart rate has two services associated with the profile or device, and the heart rate service has three different characteristics, and each of those characteristics is going to have a value, a property, and then an optional descriptor. So let's take a look at the first part of this lab. We're going to use the board as the server and then our cell phone as the client. So this is the code, and we're going to break it down quickly. So the first bit in orange describes and creates the server with the UUID specified in the first two lines, just up here. And again, these are randomly generated. And in fact, if you actually open up the server code, it actually has a link to generate these. So the green bit now is instantiating our characteristic. So this is saying this is our characteristic and this is the UUID specified with it. In this characteristic, there are two properties. There's read and then there's write. There's a possibility of 4 different properties: read, write, notify, and indicate, but we're only using read and write. And then the part in gold is just us setting the value. So the value of this characteristic is just how are you liking this demo so far? And then lastly, that purple pretty much tells our Bluetooth service to start advertising, or pretty much saying, start telling people that it exists or that it's here. So this is the first part of our 4th demo. We're just going to test out the Bluetooth server code we just saw. Now, the code you saw before was originally created by Neil Colbin and Evandro Coppercini. It was then appended by Ravi Teja, and then I modified it myself, again, with that LED you saw earlier. Some of the changes is just like the device name, ESP BLE server. Also the initial message. More importantly, one of the bigger changes is just, again, let's work with that LED again. When we pass a value of on to the board through Bluetooth, it's going to turn our LED on. And if we pass a value of pretty much anything else, it doesn't have to be off, but anything else, it's going to turn our LED off. So if we just upload this right now, I've already pre-compiled. So in order for us to work, we do need a Bluetooth client. So we are going to use our phone, and we're going to use an app called NRF Connect. And NRF Connect allows you to essentially communicate with Bluetooth services or Bluetooth devices on a macro level. So you can see the specific characteristics and services, and you can also configure it as a GATT server as well. So if we go in and just press scan, it's actually already there, but let's just press scan. And if we connect to this device, and this is ours, ESP BLE server, and this unknown service, that's what we specified. And if we download that value, you can see, hope you're enjoying this demo, that's the initial value of the characteristic. And remember, it's read and write, so we can actually write to it. So let's just send in some text and send it the word on. So now that we've sent that over, we can see that it turns our LED on. And if you recall, if it takes in any value that isn't on, let's just send it 0A. It's a little slow, sorry, but yes, it'll turn it off. And we'll just try that one more time on. And the LED is on. Ta-da! So that's the first part of this demo. The next, we're going to see how you can use two ESP32s to act as a Bluetooth and a Bluetooth client and server. So this part is going to be a little bit more code heavy. There's a lot more work to getting a client to work in BLE because there's a lot of variables we have to manually set. But we'll go through it really quickly. So the first bit in orange is setting the different static variables, including that same UUID of the server that we are going to connect to. They need to be the same or else it won't work. So the green is the function for printing to the serial monitor that we're receiving data for the characteristic. The purple is a class that describes what's going to happen when we disconnect or connect. Here we have our connect to server function. The orange creates our client, and the purple searches the connected device for the right service UUID. Again, we need to have the exact same one. And then the green checks the right characteristic UUID. And the last bit just reads the initial set value from the characteristic from the server. So if the server sets it as how are you liking this demo, it's just going to read that. So next we have another class. This was used in that previous function. It's pretty much the board looks for devices that are advertising and it checks if it has the right service ID. And the purple is a setup. This is where we initialize all the variables and the Bluetooth client starts scanning. So lastly, we've got our loop. The first half of it checks if we're connected, and the second half checks if what is going to happen once we are connected. So in this case, the default example program built into Arduino sends over the amount of time since the board's been booted up. And if we're not connected, we're going to just scan and start. We're just going to scan and start all over again. Okay, so welcome to our last part of the demos. So let's take a look at our setup. So here's a server from earlier. It's still running our server code. So if you send on to it, it'll turn the LED on. If you turn off or anything else, it'll turn it off. So here's our client. And if you can see, there's a jumper cable attached to it. And this is the touch sensor from earlier, but this time I've actually taped a piece of foil to it. This way we can just easier for us to set off. So you can kind of guess what we're trying to make, but let's just look at the code. So as mentioned before, this was a modified code by Ravi Teja that I've just changed for our purposes. And really the only modifications I've made are just right here. It's pretty much just taking a reading from our touch sensor from that piece of foil. And if it's greater than a certain value or less than a certain value, it is going to send a signal of on or off. Remember, when we get high numbers, it means no one's touching it. Low numbers means someone is. And afterwards, it's going to write that value to the characteristic, and it's going to beacon it back to our server. So it's already been compiled. Let's just upload. So since this is our first time connecting Bluetooth and client together, we may have to just reboot both using that physical button that we mentioned earlier. So we're just going to press reset, and if you can see that it's created a client connected to the server and it's found the right service and characteristic UUID. And if we take a look down, it's reading the value of the touch sensor, and because it's saying it's greater than 38, it's just sending the value off. And if we have off or not on, it's just going to keep it off. Now if we touch this piece of foil, it's going to turn it on because it's reading a value less than 7. So just one thing is that we are using a delay, if you see in the code, it's delay 500, between writing to the server and reading from the client. So you'll see it'll pull only about 1 second. So you'll see a small delay there. Also, one last thing to note is that these are Bluetooth devices. Right now, they're both connected to the computer. So it looks like everything's connected, but they'll work in separate rooms, they'll work on separate levels. Bluetooth Low Energy has a maximum theoretical distance of 100 meters. You probably won't get that on these boards, but like it'll still work on, I don't know, a couple floors at least. So just applied demo, we have our foil sheet here, and in the red dot in the distance, that is our LED circuit. So for the purposes of this demo, I've just removed the resistor from our LED circuit. I don't recommend that because you'll burn your LED out quicker, but for here, we just did it so it's a lot brighter. So in 2 different rooms, connected via Bluetooth, and if we touch this, it'll turn on the light in the distance. Just one more time. And there you go. So any questions about that final demo? And yes, I do have a Kingdom Hearts 3 background. Thank you for noticing. In regards to buffer and overflow, you can specify buffer sizes, and depending on how you actually program this, if you were to program this in C, it would require you to specify the size of what you're sending. Because we're using Arduino, it's kind of taken a more smarter approach based on what we send. If it sees a too large value, to my knowledge, it will just time out and it just won't accept it just won't accept the update. So last bit, why do we care about any of this really? So first we have to acknowledge some of the limitations of the work that we just did. So ESP32 programmed in Arduino is not commercial grade, and it could never be used in commercial environments. So real devices need tighter circuits, and the programs used in Arduino are way too large because of all the imported libraries. The firmware itself is also not good for fine level control, and real devices would require like a real-time OS. If you remember earlier, we tried to set a delay for 5 seconds, but it felt more like 3, and that's not an acceptable margin in IoT devices. Also, same as how using sleep in programming, in software programming is bad code, using delays in hardware is also bad code. So why are IoT devices exactly so insecure? There's a few foundational reasons. One is that some companies are more focused on the product working than they are on whether it's secure. It's also very pricey to produce hardware since there are also software and licensing costs associated with it. Also, since there are similar items on the market, products will focus on competing with different features and their price rather than implementing security. And to implement security would require more memory in the design, which could also like drive up the production price. And lastly, just remember that security is a process. So because of that, even if you were to design a secure IoT device, if it never gets updated, then you can't really say that it's secure. So what can you do? You can try it out. There are hundreds and hundreds of examples. I think I did a Google search and one page said 600 examples and tutorials for you to follow. There's also dozens of parts that you can get that makes this more versatile. You can get LCDs, you can get OLEDs, you can get different sensors. There's also an NFC shield, and if I'd had the money, it's about $50. I would have done a demo on that as well. You can get a camera. There's even a tutorial for facial recognition on an ESP32. If you want to challenge yourself, you can try programming this in IoT Development Framework, IDF, instead of Arduino. Just know that's going to be a really long learning process. And if you're not really interested in building them, try breaking it, right? Try to do a Wi-Fi deauthentication attack. Try to do a Bluetooth eavesdropping attack. You can do that by exploiting the GATT service. Or you can just try sending random voltages to the hardware and just see if it does anything. And I know you're kind of laughing at that last one, but that's actually exactly what happened. In 2019, they found that certain voltages at power up would actually enable them to read the flash encryption and grab the secure boot keys. So I was lucky enough to see a talk by Thomas Roth regarding this at Sector 2019. I thought it was the coolest thing. So we mentioned before, we are doing a raffle. So 2 winners will be receiving a set of ESP32s along with the peripherals listed here. This would be enough to make almost all of the demos in the video except for that last one. And for those who don't win but are interested in trying it out, all the materials used will be uploaded sometime this week, including the slides with the embedded demo videos and the code samples as well. And also I'll provide a text file that has a list of all the components and where you can get them. Okay, any final questions? Yes, yeah, there's a, I'm not in charge of the raffle, that'll be Mr. President, but once they tell me who the winner is, you get sent a kit.
Awesome. Well, thank you, Jess.
Thanks.
No problem. Just in case everybody didn't know, Jess was actually a C3X participant. She completely rocked the competitions. There was like if anybody hasn't participated in C3X, there's like a interview that you have to do with like the mentors that are there. And her presentation, she completely rocked it.
That was also Connor, so
yeah,
kudos
well,
to Connor.
yeah.
He's not here right now, though.
So not only is she like really brilliant, but an amazing teacher, and I'm like, you did a phenomenal job. So thank you so much.
Oh, thank you.
In terms of the raffle, what we're going to do is Christian will actually post a survey for the presentation for today. What we ask is you complete the survey. Once you complete the survey and submit it, you'll get a confirmation message. In the confirmation message, there's a password and another link. That other link is actually the entry for the draw. And just write down the password, because in order to submit the entry for the draw, it's going to ask you for it. So just to repeat it once more, complete the survey. The confirmation message will give you a password and a link. Click the link, fill it out. All it asks is for your name, email address, and Discord handle. And it'll ask you for the submission key. Just enter that, and then you'd be submitted for the draw.
Can execs apply for this survey?
That's yet to be determined.
I'm just kidding.
And just to answer Bayuman's question, so NFC, near field communication, it's short range communication. So if you've ever you're shared an ID card, that's NFC enabled. So when you go and to the school and you scan your card to get into a classroom, that's NFC. And that's why it would be a really cool research for us as security students, just because so much physical security relies on NFC. I'm gonna stop streaming now.
Awesome. So if there's no more questions, we'll still do a game night tonight. Maybe go grab dinner or something to eat. If you're interested in joining us later, maybe 9:30 we reconvene and just hang out for a little bit.
Sounds good. Thank you just so much. That was awesome, yo.
Unreal talk. Yeah, that was honestly
dope.
incredible.
Cool. Glad you guys liked it. I will talk to you guys soon.
Peace.
Great. Have a good night.
Take care, everyone.
See ya.